So because in the exponential terms, it is
Yeah,
that it is negative 0.1 actually.
correct. The point is clear, very clear. See, even for the uniform plane wave, when you look, what is the equation you got? E naught e power minus gamma z and e power j omega t into ax cap. Fine. This is for the uniform plane wave. By assuming the wave propagates along positive z. So when you are assuming the wave propagates along positive z, in the equation, you can see here you will get negative z. So similarly, if suppose if the wave is propagating in negative z, you are going to get an equation something like this. Am I correct? So in your previous case, when I was solving the wave equation, you are assumed that the wave propagates in positive z. So in the equation, you got negative term here. So it's quite exact opposite. So similarly, if you are assuming the wave propagates in negative z, it will reflect positive here. So in the same manner, you can have a look on the amplitude term. This represents the amplitude of electric field in the direction of propagation. So there is a variation along the positive y. If nothing is given means it's a positive number. So which means actually the wave is propagating in the negative y. So the same concept here, exactly opposite. And what is the direction of electric field here? What is the direction of electric field here? Good. AZ. You can straight away see here, electric field is propagating along z direction. I mean flux is. No audio. Now, what is the magnetic field direction? My point is, what is the magnetic field direction? Negative x. Correct. So because you can see here, the direction of propagation is equal to E cross H. So in this case, the wave is propagating in the negative y. And you can see electric field is in the AZ direction. So magnetic field has to be there in negative x. Suppose if I assume magnetic field in positive x, Az cross Ax reflects Ay. So to have the negative Ay, magnetic field has to be there in negative x. Now are you comfortable? If any equation is given, will you be able to find out what is the direction of propagation and what is the magnetic field and electric field direction? Yeah. Will you be able to find out now? Shall I give one more example just for the practice? So all of you see this equation. So subjected to this, you have to tell me what is the propagation and what is the electric field and what is the magnetic field. Quickly, what is the propagation direction? First answer. Yeah, propagation will be along positive z.
Positive Z direction.
Good. Magnetic field, I have given magnetic field is
AY.
in y
AY cap.
direction. So what should be the electric field direction now?
Minus AX.
Is it correct? Electric field minus ax or plus ax? You can see here, E cross H should be propagation direction. Right now, the wave is propagating in the z direction, positive z, and your magnetic field is in y direction. So your electric field has to be there in positive x, because ax cross ay will be positive az. So it should be in positive x. Agree? Okay, anyhow,
Yes,
some
sir.
more examples we'll see when we solving the problems. Understood? Any questions you have? Clear. Yeah. Now we'll see the propagation constant. So in our derivation part, when we are solving the wave equations, so we come to one of the parameter there, if you remember. So I have told del square E is equal to gamma square E and del square H is equal to gamma square H. There I have given the value of constant gamma square is equal to j omega mu into sigma plus j omega epsilon. In our derivation we got, you can have a look on it afterwards. So this is gamma is basically said to be the propagation constant. So when you see the gamma propagation constant, this can be expressed as hello.
Sir, no audio.
Yeah, I don't know something why it is my status somebody is taking from me. Presenter status. Yeah, now am I audible? Yeah. So suddenly I don't know why it is what it is happening here. The presenter status itself somebody is pulling from me. Okay, we'll solve this problem after discussing with Dinesh. Then anyhow, we can see here. So the propagation constant, whatever I have written here, since it is a complex number, and I can express it as some real part plus imaginary part. So basically, what is this real part indicates was the attenuation constant. So typically speaking, this I can call it as an attenuation constant. And this beta is basically called the phase constant. So the significance of what is this propagation constant represents was how the amplitude of the wave propagates and how the phase variations are happening in any medium. So alpha real part represents how the amplitude varies as a function of z, and beta represents how the phase varies with respect to the distance. So that is the significance of the propagation constant. So I was giving one assignment to you. You take this equation and take the square on both the sides. Okay. So when you take square on both the sides, you are going to see something like this: j omega mu into sigma plus j omega epsilon is equal to alpha plus j beta whole square. Right. Now this will be same as alpha square minus beta square plus j into 2 alpha beta. Now you compare the real part and you compare the imaginary part and try to find out what is the value of alpha and beta. So this derivation I request everybody to do and share the explanation in the WhatsApp group. Okay. After doing this, you are going to get these equations. You can verify that. So these are the equations you are going to get. Just square on both the sides. So I request everybody to do and verify the answers with this. But you need not to remember these two equations for the gate point of view. I am not asking you to remember these two equations, but just as a practice, you can verify that. You compare the real part and imaginary part and go ahead. You find out this value of this one. So alpha is called the attenuation constant. So basically the attenuation constant is measured in the units of Napier per meter. And the phase constant is going to measure in the order of radians per meter. That we will discuss it afterwards, not a problem. And I request everybody to solve this and post the explanation in the WhatsApp group. Okay. So the main significance of the propagation constant indicates the real part of propagation constant says the variation of the amplitude with respect to space, and imaginary part represents the phase variations. So keeping it in mind, so I can say gamma is said to be alpha plus j beta. Alpha is the attenuation constant, beta is the phase constant. So once again rewrite the equation for electromagnetic waves of a uniform plane wave. So there we have seen E naught e power minus gamma z e power j omega t into electric field is in x direction. So similarly, magnetic field H naught e power minus gamma z e power j omega t a by cap. So if we substitute gamma is equal to alpha plus j beta, you can substitute gamma is equal to alpha plus j beta, and how this equation becomes now? E naught e power minus alpha z e power j omega t minus beta z. You can verify that. Is it correct or not? So similarly, H naught e power minus alpha z and e power j omega t minus beta z a by cap. So just I was replacing gamma with alpha plus j beta. So if you are putting gamma is equal to alpha, you will get E naught e power minus alpha z. And the imaginary part, if you put j beta z, I was clubbing together with omega t. So that time it will happen like this. So the reason being why I was writing this one was, now you can see the equation. The first part represents the amplitude variations. You can see here as the z varies, how the amplitude is going to vary. You can see from the first part. And this second part you can see here, this represents the phase variation. I hope you got my point. So whatever the equations I got for the uniform plane wave, I was rearranging it such that my first part represents the attenuation and the second part represents the phase, so that you can easily visualize what is happening here. So the attenuation part is always justified by the alpha value, and the phase is given by omega as well as beta. So that we will see how the phase varies with respect to time as well as the distance. So do you have any questions here to ask? Yeah.
Sir?
Yes.
Sir, is there any particular reason why we put E of z comma t z first and t second?
No, nothing else is there. It's not like that. Because the only thing was, when any wave is propagating in space, we always want attenuation and phase, right? We used to verify that.
So once again, no audio. Hello?
You got my point, what I said?
Actually, there was no audio in between.
Today, so much of interruption is happening. I don't know the reason why. So what I try to say was, because Z, why we are writing more important was, because when the wave is propagating in a medium, always our concern is what is attenuation and what is the phase variation. Time is the least priority variable, right? Hello?
Yes, sir.
Yeah, because Z is having more priority because we want to analyze the wave in terms of space. We are giving more importance for the Z. That's it. But there is no logical reasoning for this reason.
Okay, okay, sir.
Yeah,
Okay.
yeah, okay. Okay, with this, I will give one more, two more examples. You just tell me how will you analyze that particular wave? Now, am I audible?
Yes, sir.
Okay, anyhow, we'll see the last one today, and tomorrow, once again, I will try to speak to Dinesh sir regarding this problem because I don't know suddenly what is happening here. Suddenly, the screen itself is going out of my control. So, I will discuss all these issues with him. So, anyhow, before the concluding session, you can try to answer me this one. I will give the two equations here, and just have a look on this. So, by looking at this equation, can you tell me what is the direction of propagation and electric field direction and magnetic field direction? I was giving these two equations and solve. So for the first one, what is the direction of propagation?
So negative x.
Reason?
Sir, it's omega t plus beta x.
Fine, correct. Because actually if we compare with the previous equation, whatever I have given, that is of this form. If you have any doubt, you always compare with uniform plane wave. So this is the equation for electric field which is propagating in that direction. So of course you don't have any amplitude term here. Verify the propagation direction, right? Because whatever con I given, it's just simply a number. It is not a function of distance. So in that case, what you need to do, you just have a look. So whenever there is a negative sign here in the phase term, which means that the wave is propagating in positive z. So either you can have a look at amplitude variation or you can have a look on the phase variation. So the sign is present at that time, the direction of propagation is opposite of that. So since there is no provision to see the amplitude variation here, let us look into the phase part. So in the phase part, there is plus beta x, so the direction of propagation will be negative x. And your electric field is there in the y direction as given here. So can you tell me what is the magnetic field direction now? Quickly, you can reply here. What is the magnetic field direction? Everybody. Electric field is there in y direction. Magnetic field is there in which direction? So the reason was E cross H should be propagation. Yeah. Magnetic field is there?
Minus Z.
Minus Z, correct? You can verify. And for the second one, what is the direction of propagation? Anybody
Positive
reply?
Y.
To Y. Magnetic field?
Z.
Electric field? Electric field. Electric field is negative X or positive X? Can you reply here? Negative X. Good. You can verify here if you want. Minus AX cross AZ should be equal to AY. So this is your direction of propagation and this is your E and this is H. So AX cross AZ will be minus AY and minus into minus will be plus. Correct. So electric field will be negative X, magnetic field is in Z, and the direction of propagation is in Y. And at the same time, is it a lossy medium or a lossless medium? So have a look on the first equation. Is it represents the equation for electric field in a lossy medium or a lossless medium?
Sir, lossless.
Reason?
No attenuation factors.
Good. Because you can see here the amplitude is a constant independent of the distance. Because if you figure this factor with E naught e power minus alpha z, your e power minus alpha z factor is 1. So there is no variation, which means that your alpha will be 0. Correct, right? If you compare this equation with the classic equation of the uniform plane wave, you are going to get some things, right? This is our classical equation. If you compare the amplitude part here, straight away you are going to get a constant. So which means that your e power minus alpha z equal to 1. So your alpha is said to be 0. So when alpha is 0 means the attenuation is 0. Alpha represents the attenuation constant. So in other words, you can see here, electric field is straight away I have given a constant value. Constant value means it is not a function of distance. So irrespective of the distance it is traveled, your electric field is going to maintain amplitude of 2. So the simple shortcut here was, if you see the magnitude part of either electric field or magnetic field, if it is just a number, the medium is considered to be a lossless medium. Because or suppose if you are having this kind of variations, if you are having this kind of variations, is it a lossy medium or a lossless medium now? Can you reply? Is it a lossy medium or a lossless medium? It is a lossy medium because there is a variation of amplitude in the y direction. Okay, it is a lossy medium. Suppose the amplitude is independent of this distance, then you can consider it as a lossy medium. Suppose I have this equation. Okay. Is the equation correct? Whatever I have written here.
No, sir.
No. Where is the mistake here?
So in magnitude part, wave is propagating along positive x, but in phase it is negative.
Correct. So that gives indication. Your amplitude is defining one thing and defining something, which will not happen. If the wave is from a certain direction, amplitude phase variation should happen in the same direction. So this equation itself is wrong. So you can never expect the amplitude will be negative and phase will be positive. So this will never happen. You should keep in mind. Okay. Okay. Anyhow, today we'll stop because we are getting so much of interruptions, and we'll try to correct all these things by the next class. We'll see
Sir,
how it goes.
sir,
Yeah.
can you please repeat this thing again? Means like, sir,
This
is it
last
like?
one, huh?
Yes, sir.
Yeah. So this one actually represents, see here, when you have a wave, consider here, this is my electric field propagating in a certain z direction. Okay.
Yeah.
So here, the amplitude is also varying along positive z, right? The wave is propagating along positive z, which means your direction is also happening along at z equal to 0, amplitude is 0. At z equal to this point, amplitude is maximum. Agree?
So what should be the correct then? Mean it should be 0.1 y.
No,
Then
no,
it
no.
will be correct.
It should be both minus or either it should be both plus. Not this one. This is correct. One is I was talking about.
Yeah. Second one means like,
Yeah.
okay, means
Either
the
it should be
sign.
positive or both negative.
Okay.
Okay, understood? Why? Because you can see here amplitude is also varying in Z and phase also varying in Z only because phase is 0 here and pi by 2 here, 180 here, 270, 360.
Yeah.
That's it. Right? So you will never have a wave in something like this. Nobody is going to give you. Just understand the purpose I was giving this. You should
Okay.
have both negative or either.
Okay, sure. Got it.